All right, let's talk about the heat ripple effect now. It's just assigned to a piece of geometry here, just a simple plane. And you can see there's a little bit of an offset there. That's from the refraction in the material. The inspiration for the material comes from a material here in the starter content. So if you go to starter content and then particles, and then within the materials, it's used by, I think, probably the P-fire. These are all set up with Cascade, which is an older particle system within Unreal. And the material itself is this M heat distortion. Take a look at it. What's going on here is there is a texture sample of a normal map. This is water, which is also included in the sample content. There's a panner on it, so it's got a little animation. And then we're doing a lerp here. And this lerp is basically blending between a flat normal map and the version of the normal map with the water. And then this is going to be the alpha. So if you do a little right click and go to start previewing node, and let me set this to a plane, the alpha is going to be this circle. I'm not sure why they didn't use just like a radial gradient, but anyway. So this is the alpha. So everywhere that it's white, we're getting the moving texture. I'll show you what that looks like here. Let's see. So if you move it around, you can see what's happening. And then there is a dynamic parameter here, which is the lifespan of the particle. The assumption is there's going to be a bunch of planes, little cards generated by the cascade particles. And then it's just assigning this texture to another lerp here. And we're lerping between 1 and 1.5. And what that means is 1 is going to have no refraction and 1.5 is going to have a lot of refraction. So as the particle, I guess, in this case, let me look again. So as it ages, so this will be when it's born and this will be when it dies, according to this, which seems reversed to me. But anyway, this is the inspiration. I don't have to unpack it all, but I'm not doing any dynamic parameters because I don't have any particles. I'm just doing something very similar here. So here, rather than using one normal map, I've split the green channel and the red channel, and I'm referring to each one individually and doing a separate panner for each of them. So if I do, I guess I can't, I don't know if I can do a preview on this one. Doesn't look like it. But I can potentially come over here. I'm going to need to set this to a higher value. Set up to 1. So we can preview this node. So that's what one of these changes is doing, I guess this one. And then, and I've also got a texture coordinate here, which is increasing the scaling a little bit. And then we can do a preview on this one, and it's just going to be the same thing, just going in a slightly different direction. And then those all come together in the form of a normal map. So I have this normal map where, yeah, in fact, we could probably just look at this guy. So it's basically doing that, right? And then for my alpha, between my lerp, so this is my flat normal map thing, or just like a completely smooth surface. And then this one looks like this, where this would evaluate, I guess, it's kind of hard to show you for sure, but this would evaluate as a very bumpy surface, right? So the alpha for that is going to be this, which is just graded by a couple of radial gradients, where this one is inverted, and then they're multiplied together. And the reason I do this is I want the area right in the middle. Oh, look, that's pretty convenient. So right in the middle, let me see if I can hide some of this stuff. Doesn't look like it. But the area, like right in the middle of this plane here, doesn't have any refraction going on. But on the outside it does. So I basically just wanted the heat ripple to be concentrated on the outside here of the geometry, so that this was easier to read. All right, let's see, where were we? Heat ripple. Yeah, so this is the alpha. So where this is white, we're going to be getting this, the stuff with the bumps, and where it is black, we're going to be getting the flat normal map. So what is all this stuff doing here? If I come over and start previewing this node, it's going to look like that, right? So this is being fed into a material that already just has kind of a high refractive index. It's not really high, but for some reason it's like 1.08. That seemed to be the sweet spot, even though in the original one they're using 1.5 as their max refraction, which is like obviously a higher value than 1.08. But you can see the result here. That looks pretty good to me at 1.08. So that's, after some testing, that's the number that I landed on. So there is this parameter, normal strength. I don't really want this stuff going all the time. I want to drive it as everything else via a timeline in the blueprint. So I have this normal strength parameter. If I set this to 0, we're going to get this as the normal map that is being fed into the refraction. The way the refraction works is it basically just, if there's any kind of, you can kind of see here, if I maybe grab a sphere, I got to stop previewing this node. So this is no refraction, and there's like very little boundary there. But if I set this to 1, let's see what it might, I'm not sure how it's going to update because it's a sphere and the UVs or whatever they're going to be as opposed to a plane. But anyway, so that's how it all works. Let me set this back to 0. I'll show you the stuff in the event graph. We've got the reference to the plane heat ripple, a timeline, and then this node here will allow me to set a parameter on a material. In this case, it's a scalar parameter, which means it's a single decimal point. Sorry, that's the old one. I'll go ahead and close that. If it was a vector, I would need a vector parameter here. I just say what the normal strength is, which corresponds to what I have named this, and then it'll go ahead and update it. The heat ripple here starts off, I believe, at 1.5, and then drops to 2 pretty quickly, and then tapers off over a few more seconds to 0. So that is how the heat ripple effect is created.